So far we had seen the combinational circuit. So there, as soon as we feed any input to a gate, immediately we used to get the output. So I have inputs and immediately I'll get the output, but there will be some very small, it can be nanosecond or picosecond range propagation delay, but it will be kind of negligible. I mean, I cannot say that it's completely negligible. It is the main contributor for your setup and hold violation in the digital circuit, but that delay, it may not be noticeable, right? I mean, when we do that kind of critical violate those things. So, but in case of sequential circuit, the output is completely time dependent. In the sense, whatever the output you are going to get, that will be with respect to edges of the clock. So if I say I give input at certain duration, so output, I have to wait till I get a clock edge. So clock is nothing but a square signal, square wave or sinusoidal wave signal. So either positive edge or negative edge, depending on the hardware what you have designed. And also, so I mean, if I remove this input, so for example, in this case, in the combinational circuit, if I remove this input, output also will go immediately. But the sequential logic are memory systems. So for instance, if I get output, if the output is latched at any edge of the clock, if I remove the input data, right, this output will remain same. I mean, so it has a memory. So it is a memory system. It's not a memory-less system. So always here in the combinational circuit, we represent in terms of input output. Here we represent the output in terms of state. When I say a latch or flip-flop, it can store or it can deal with one bit. That is why I call this as one bit memory. So flip-flop or latch, we also call it as one bit memory. Where do we use this flip-flop? It is mainly used in counter, your adder, and all your digital circuits like microprocessor, microcontroller. You use your smartphone. So smartphone is made up of a processor. So that processor basic element will be again flip-flop. So when I say a flip-flop, this can be constructed usually using NAND gate or NOR gate. So each flip-flop you will have two stable outputs. Q and Q bar. So hence this flip-flop also is called as bistable circuit. So I said like this output will be coming into effect based on clock. So clock usually a square pulses, series of square pulses. Usually this will be derived from oscillator. or crystal. Crystal is again oscillator. Okay. So this clock, we also, you in the digital electronics, you frequently come across terms like positive edge. Like there is a variation from low to high, that we call it as positive edge, and from high to low transition we call it as negative edge. So usually in sequential circuits, you will come across two terms. One is latch and another is flip flops. So this latch usually it's a level sensitive. You can see these levels, right? Level sensitive. Whenever it is high, some state will be coming into effect. Whenever it is low, some state will be low. But flip flops usually edge sensitive. So the output, so you will be giving some input. We call it as D, data. So this data will come into effect at the output only at the edges, not on the levels. That's why we call it as edge triggered. So if it is on the positive edge, then we call it as a positive edge triggered flip flop. It is at the negative edge, that is like from high to low transition, then we call it as negative edge triggered flip flop. Next important flip flop we frequently use in industry, we call it as SR flip flop. So S stands for set, R stands for reset, set or reset flip flop. So the symbolically we represent it as will have S as the input, R as the input, and we will also have clock, and we also have Q bar bistable output. So in order to build this SR flip flop, we can use NAND gate or NOR gate. So using NAND gate, the circuit looks like this. I will have one NAND gate. I will have another NAND gate. So yes is the input, R input here, and I will have clock connected to this part, and this output fed to another NAND gate, and this output fed to one of the NAND gate. So output of this NAND gate will be connected to input of this NAND gate. So input of another input of this NAND gate is connected to output of this NAND gate. So this is Q, this is Q bar. In order to analyze this, right? So we have to start putting the values, like we usually state as a state table. So we have inputs, clock, S, R, and Q n plus 1. And what is the mode? So Qn plus 1 is nothing but after giving the clock, what is the new state of Q? So I will have some previous value of Q, right? So I will give some clock. So after giving the clock, how my clock look like? So that is the next state of Q. So initially, let's consider like clock is 1, both S and R is 0. So Qn, like let me consider this Q is 1, Q bar is 0. Now both are 0. So what is the output when one of the NAND gate input is 0? Any one of the input is 0. Always it will be 1, right?
Yes.
NAND gate output is 1, 1 because both S and R are 0. So output here it will be 1. So one of the input is 1. So now my NAND gate output purely depends on what I feed in the second input. So if I feed 0, this Q will become 1, correct? And since this is 1, input is another input is also 1, 1, 1, you'll get 0. The output didn't change. Previously it was 1, 0. Now also it became 1, 0. Now let me change this. Like previously I kept it as 1, 0. Now I'll make it 0, 1. So since 0, 0, it will be 1, 1 only. So this 1 is fed to here. Since both are 1, 1, my output is going to be 0. 1, 1. So output is going to be 0. And here, since it is 0, one of the input is 0, here it will be 1. So whatever the output it can be, Q bar. If I feed 0, 0, that output is not going to be changed. It will be as it is. Do you agree with this?
Yes.
So for that purpose, Qn plus 1 will remain Qn, same. It doesn't change. So this is nothing but my mode is previous output mode. Okay, whatever the previous input is there, that itself will come as the output. Next, I'll keep clock 1, S 0, R 1. Let me assume Q, okay, let's see this, what will happen. So since S is 0, here it will be 1, right? So, and R, since R is 1, clock is 1, here it will become 0, correct? 1, 0. 1, 1, it will become 1, 0. So since this is 0, and previously let me consider initially it is 0, 0, 0, it will become 1. And this 1 will be fed here. So 1, 0, it becomes, yeah, 1, 1, 1, it will become 0. So whenever it is 0, 1, it will remain 0, 1. Again, let me flip it. Okay. It previously also it became 1, 0, 1. Now let me flip it. What will happen? Let me consider instead of 1, 0, 1, I'll keep 1, 0. So 1, 0. So here it is 0, 1. So that's why 1, 0 remains same. So this is 1, 1, 0. It will become 1. This 1 goes here, 1, 1 becomes 0. So irrespective of what is the output, so it is forcing that to become 0, 1, correct? So Q bar is becoming 0, 1 for the input of 0, 1. So Qn plus 1 will become 0. Qn plus 1 bar will become 1. So for 0, 1 input, Qn plus 1 will become 0. So this mode we call it as reset mode. Clear?
Yes.
So now we'll consider 1, 0 case. When I keep it 1, 0, this will become 0. This will become 1. So let me consider it previously it is 0, 1. So 1, 0, this will become 1. This 1 will go here. 1, yeah. Let me just erase and reanalyze it. So 1 0 1, whenever this is 1 1 1 0 0 0 1 1. So here also 0 1. So this 0 1 1 1 0. Okay, something I missed. 0. So 1 1 1 0. So here one input is 0. So if one of the input is 0, forcefully it will become 1 only. So 1 1, this will become 0. So the 0 1 got changed to 1 0. Let me assume now it is 1 0 only. So in that case, 1 will be fed back to here 1 1 0 0 0 1. So irrespective what the input other states are, so it is forcing to, like, whenever the input is 1 0, my output is forced to 1 0. So this is 1. So this mode we call it as set. Clear?
Yes, sir.
Now you consider clock is 1, S is 1 1. So both are 1 1. So when both becomes 1 1, so this will become 0 0. When this is 0 0, since this of the things are 0, output will force to 1 1. 1 0 1 1 0 1. So see, in a bistable format, q, if q is 1, q bar should be 0, correct? But you are getting 1 1. So qn plus 1 will become invalid. Invalid. This is the invalid state. Okay? Because it doesn't make any sense, right? Q bar cannot be 1 1. If q is 1, q bar should be 0. So whenever you feed 1 1, so in SR flip flop, it is not recommended to feed 1 1. That will be invalid also. So now if clock is 0, since this is 0, forcefully one of the inputs are, both the inputs are 0, right? 1, this also will become 1. Correct? So this is 1. So if, for example, if you have input as 0 1, so 0 1 1 1 0, again it is 1 1, it is 0. So 0 1 remains 0 1. So if it was 1 0, that also will remain 1 0. So irrespective of the input, right? If clock is 0, it will be previous. Whatever the previous input is there, that will remain as it is. Okay. So if you change this NAND gate to NOR gate and keep the circuitry same, this should work. So the circuitry will remain same. Okay. I mean, explanation also it's same. So that's where, like, I'll just